Welcome to my channel, viewers. This is my third video. This is my recent third video of derivative. And recent first video was published on the two videos I published for the first principle and some basic conception of derivative was done by me on the second video also. Okay, now also here are the 21 problems, and these problems were taken from the book of I.S.C. Okay, and not only this is taken from the book of I.S.C. and students see carefully. This type of problem are also occur on the some books. Okay, and same pattern, and see carefully the differentiation of the next is this video. Okay, and this is your differentiation for question number 1 here. Say y is equal to log to the base e here, that is cosec x and cot x. Okay, and differentiate both sides with respect to x here. Okay, now dy dx and ddx of log to the base e, and this is function is cosec x and plus cot x. And log of something, derivative of log x is what? 1 by x, and this is later as with the x. This is called cot x and cos x. And again, differentiate of the value of the which are given here, that is x, and here is given that the cosec x and cot x. Okay, cosec x plus cot x, and differentiation of cosec x is minus cosec x and cot x is minus cosec square x. Okay, take a common minus cosec x, then we got here cot x plus cosec x and divided by cos x plus cot, and these are cancelled, so minus cosec x here. Okay, see, this is the number 1. And number 2, again say the students here is a variable. The differences of the function like x to the power n, x to the power 100. So 100 be a constant, either a to the power x, where a is a constant. So their difference for the first, that is x to the power 100, then be 100 into x to the 100 minus 1. And the derivative of 100 to the power x, if given the function is this, so that will be 10 to the 100 to the power x into log 100. So this type of two function But see here x to the power x, this is variable and also these are variables. So we can't apply these two rules. Okay, so that's why that type of function always we have to take on the logarithm on both sides. Then we can proceed the differentiation. Okay, so log on both sides, then the power be as a x, so x are come from on the front, and this is the rules of logarithm. Now differentiate both sides. Again, we have write the language always differentiate both sides with respect to x like that. Okay, so now here ddx of log y, and that is ddx of x log x, and that would be differentiation of like this is a function of y, so you can take y with respect to y, and also, and this is here ddx of x, y are balanced. Okay, see, and differentiate u into v, here is x into u into v log x, and this is f to the base e here. Okay, and plus log x to the base e, and ddx of x is 1. I have written by this method, but the derivative of log x is, that is 1 by y, and also differentiate here the function which is given here, so you can write dy by dx also. Okay, so system is this 1 by y and dy by dx x here, and same as 1 by x, this is the function of x here. Again, if we differentiate x is 1 here, so but this is log x and this is here 1. So here again see dy dx is equal to y and multiply, to the on the right hand side. Okay, that is y means here x to the power x. X are cancelled, so this is here 1 and dx of x is 1, and this is okay. See carefully, students. And now different type of problem like that we have to discuss now. Okay, see. See, for 2, we have just discussed some point. Now another point, take as assume this is a Roman 1 question, and now introduce a Roman 2 problem like that. If we given that is x to the power x plus and sin x, so how can we take the logarithm on both sides? So it is not possible to take on the both the side, as it is a given that the addition of sin x. So not possible here to take a logarithm. So you have to take another variable like u. Okay. So I think you will already better understood. Okay. Now take a logarithm then. So x and log u here, log x here. So differentiate this. This is we have get 1 by u like y in the previous points. That is 2 part 1. Okay. Du by dx. And take a differentiation on both sides like u into v dx of log x here. Okay, and log x into ddx of x here. And see du dx, and that is u multiple of x, and differentiation of log x, that is x. Again, if we differentiate x is 1 here, okay, and the plus log x, and this is here 1. And u means that is x to the power x here, and that is 1 plus log x, you know. Now here we have taken the value, taking the subject to the function x to the power x as a u, and then the addition be here sin x, and differentiate both sides with respect to x here, that is dy by dx, and that is also a du dx, and now and differentiate this is as a cos x, we get cos x, and now du dx is here is this, so x to the power x 1 plus log x plus cos x here. Okay, this is the answer. And also proceed to another technique. This is a very important point. Don't need to take a logarithm. For some value like a, you can write as a e to the power log a and to the base e. So that type of system I can apply that. See here the another technique to solve this. So any number. This is a variable. We can also express as e to the power log. And here is e to the base e, and like that. And this is the technique. So you can write e to the power x log x to the base e plus sin x. Okay, in some problem there is a big formation variable to a variable. So that type of, if you take a u, if you take a something, so there would be a longest method. So this technique would be a very easiest method. See carefully, yeah. So differentiate both sides, that is du dx, and that is here, and ddx of e to the power x log x plus, and this is here differentiate sin x, we get here cos x. But first step here is so write the step here. So differentiation of e to the power something, that is something here. Again differentiation. And that is e to the power x, it be e to the power x and also differentiate to the x. Okay. So also this is a power, so you can also derivative to the power. You know, this is a chain rule which I have introduced to the previous classes. Okay, previous class. Okay, now here this is here cos x, and this can be written as like, and this with this. So in place of that, we can replace x to the power x here. And we apply the u into v method, x into ddx of log x here, okay, and also log x to the base e, and derivative of x here is 1, and this is here the we have done the differentiation of sin, and this is cos x here. So now x to the power x, and this is x, and differentiation of log x, that is 1 by x also, and here is log x to the base e here, okay. And this is here cos x. So again write here and this is x to the power x, and 1 plus log x to the power z, and this is the cos x. Okay. And also another point we have to introduce in that point. See carefully. This is a very important point, and that type of point we have to introduce another two problem, and see carefully here. So see, if you given the point here like sin x to the power and cos y, and also that is x to the power y here, and this is equal to 1. Okay, and find dy by dx. Find dy by dx. Some students you are read as a dy by dx. This is not right method to read. This would be a dy dx. Okay, this is can be read as a dy dx, not dy dx. Dy dx. Okay. See again, this is also a variable, and y. See here, find dy dx. So y and x both are variables. So this can be said that the variable to the variable. So that's why we apply the last rules, and also we don't take a logarithm on both sides as middle as a addition. So we can apply the logarithm theorem. But here we exercise like that in the previous point, part 2 there. That is e to the power logarithm and sin x to the power cos y here. Okay, this is to the base e here, and also e to the power log, and that is x to the power y, and to the base e here. Okay, this is 1. So again write this is e to the power cos y into log to the base e, here is sin x, and also e to the power y log x to the base e here, and this is 1. And again differentiate both sides with respect to x. So take a derivative ddx, not d by dx. Okay, ddx. Okay, this is ddx e to the power y log x to the base e is this is the constant, so differentiation 1 is 0 here. So again derivative, differentiate this, e to the power something is we get here e to the power something, that is cos y log sin x to the base e here, and you apply the u into v, so that is cos y and into ddx of sin x, again log to the base e sin x into ddx of, here is cos y. Okay, again plus this is you have take a derivative ddx of this. Okay, and differentiation of this is there y into log x to the base e, and ddx of y into, we can apply the rules here directly. This is u into v. You see this the step here. So y into ddx of log x, and also here log x to the base e, and here ddx of y, and this is equal to 0 here. So we can replace in this part here is sin x to the power cos y. Okay, and this is here cos y. See careful, differentiation of log x. Okay, I repeat, differentiation of log x, that is 1 by sin x, you know. Okay, and you have directly used there. And again differentiation of sin x, it is cos x. Student, I think you already better understood for this point here. Again I repeat here, differentiation of sin x, that is 1 by sin x, and again differentiation of sin x, this is cos x, and this is the technique. Log to the base e and sin x. As a question there is a find dy by dx. Oh, so that's why y also a variable and x also a variable. So find dy by dx. So here is differentiation of, okay, cos y is what? That is minus sin y. Again repeat, differentiation of y is dy by dx. Okay, and here is e to the power y log x, it means x to the power y. Okay, y, differentiation of log x, that is by x, and dx of x is 1. And this is here log x to the base e. And there is here is a dy dx, and this is equal to 0. So now find dy by dx. So we have to take a common dy by dx of these two terms. So first we have to multiply this with this and this, okay? Then we get the, like this is sin x to the power and cos y, and this is cos y, and cos y sin, this is cot x, okay? And also this is here minus, so this is a minus, so sin x to the power cos y and into log sin x to the base e, and here is sin y and also dy by dx. And first we multiply this with this, and that is x to the power y log x to the base e, and here is dy by dx. And the last part here is, if we multiply this, then we get here like x to the power y minus 1 into y. This is x to the power y minus 1 into y, and this is equal to 0. So we have to take the common here dy by dx as a dy by dx. This is the middle two term are there. Okay, now dy dx, write dy by dx. We get here, that is first we write here x to the power y, and this is log x to the base e, and minus sin x to the power cos y and log sin x, okay, and also this is a sin y. So bracket is closed, and this is equal to the two terms. These are transferred to the right hand side. Both of the sign are same plus. Okay, so we have given the sign here minus. So now see, this is here sin x to the power cos y. Okay, and this is here cos y, and this is cot equals and plus x to the y minus y into y. Okay, this is the answer. If we this second bracket are written by this, okay, so we got the answer. See carefully. So dy by dx is equal to this by this. So this is the technique. So follow the technique. If we take like u into v, this will be a long. Okay, now next point, which I have to use the logarithm, but use the logarithm here. See, this type of this type of three product are given. So y is equal to 1 minus x, 1 minus 2x, 1 minus 3x. So it would be easy if we take the logarithm. So that's why log y and log of 1 minus x plus log of 1 minus 5x plus log of 1 minus 3x square. So differentiate this is we get here 1 by 1, and also repeat here, okay, and log of x is 1 minus x, and we have to derivative the 1 minus x also, that is 1 minus x, derivative of 1 is 0 and x is 1 here. Again repeat, derivative of log of that is 1 by twice x. Again differentiation of that, 1 is 0 and twice x is 2 here. Again repeat, differentiation of that is 1 minus 3x square. Again differentiation is this. So okay, and the derivative of 1 is 0, and this is here 6x. Okay. So now dy by dx is equal to the 1 minus x into 1 minus 2x into 1 minus 3x square, as this is y are multiplied on the right hand side in this position. So the value of, in the expression of y is this, okay. And now within the third bracket we can write here minus 1 by 1 minus x. Again repeat 2 by 1 minus 2. Again repeat 6x by 1 minus 3x square. Okay, see carefully. This is for 3. And now follow the 4 here, and also root over, and this is here x minus 3 and x square 4, x square plus 4, and 3 x square plus 4x plus 5. See, this is a critical formation like root over the product of that and divided by this. So you should always take a logarithm and then after differentiate. So that is log y, and the power we hold to the power half. So we have written in the part of that as a power, logarithm power. So now log of this x minus 3, and this is their plus, so we take a plus into, so for the logarithm like a into b by c, so this is power half, so half can be written in the front of that, and so again write here log a plus and log b minus log c. Okay, so you apply that rules. Okay, log of x square plus 4, and this is numerator, so that is you can write log of 3x square plus 4x plus 5 here. Okay, and now differentiate. Okay, both sides respectively, that is 1 by y. Again differentiate dy by dx, and that is equal to half here, and this is 1 by x minus 3. Again differentiate this 1 and 3 is 0. So derivative of x is 1 and differentiate of constant is 0, like 1 by x square plus 4. Again x square is twice x and 4 is 0 here, and differentiate the term x square plus 4 here, and again see 3x square plus 4x plus 5. So differentiation is this 3x, okay, 6x plus 4 here. So now dy dx half into root over of y, this is y, is this, so that is x minus 3, that is x square plus 4, and this is 3x square plus 4x plus 5, and also this is 1 by x minus 3, and this is 2x by x square 4, and this is 6x plus 4, and by 3x plus 4x plus 5. Okay, this is the answer. Okay, next problem 5. Say this is your 5. Let y is equal to log e to the power x and x minus 2 by x plus 2 and whole to the power 3 by 4 here. Okay. See, as it is a log, we can apply the product rule, log of a into b, that is log a plus log b here. Students, there is a base e to the power x plus log, that is to the base e here, x minus 2 by x plus 2 to the power 3 by 4. So this is equal to x, and e base is here is 1. So this is e base a, and this is here 3 by 4. So log a by b. This is log x minus 2 and log x plus 2. So this is our y, and e base is 1. Okay, differentiate both sides. So ddx of x is here 1, so e base is 1 here, and this is 3 by 4. Okay, and differentiate of log of this, so you can write here x minus 2, again derivative this, derivative of x is 1 and 2 is 0 here. Again differences is this, so therefore 1 by log x, derivative of x, log x is 1 by x also, and ddx of again this, so derivative of x is 1 and 2 is 0 here. So that is answer 3 by 4 and x minus 2 by x plus 2. So this is here 1 plus 3 by 4 here, and take a LCM x minus 2 and x plus 2. So that is equal to, that is here x plus 2, so this is multiplied by this here, so minus x and plus 2 here. So these are cancelled. This is here 1 plus, so this is 3 by 4, and this is 4 by, and here is x square minus 4. So that is 1 plus 3 by x square minus 4, and take a LCM. this is here x square minus 4 plus 3. So that is x square minus 1 by x square minus 4 here. Okay. So see question number 6. See, and this is here y is equal to, and that is the x minus a minus x minus b, and this is here plus a plus b. Okay. So plus x square and sine of x cube. Okay, and this is 1 by, and this is the set, so you always rationalize this part as it is on the denominator part. So always simplify the denominator part, okay, for differentiation and also integration. And so we needed to rationalization, okay. The rationalization factor here is, I think this is a minus, so this is a plus and over x plus b here. So multiply by that, so you get here x plus a whole square and root over x plus b whole square. And next is x square into sine x cube here. So this is here root over x plus a and root over x plus b here, and here is x plus a minus x minus b, and x square into sine x cube. Okay, and this is here x and x cancel, so 1 by a minus b and root over of x plus a whole to the power half and plus whole to the power half x square sine x cube. This is here y. So dy and dx 1 by a minus b into ddx of that. So half x plus a whole to the power, so minus of that into, again differentiate this, and this is 1 and this is 0. Again this is whole to the power half. So write a step here. Okay. Then dy by dx equal to, again right here, a minus b, and ddx of this is your x plus a whole to the power half, and this is ddx of x plus b whole to the power half, and again this is a u into b. You can apply x square into ddx of sine x cube, and then sine x cube into ddx of x square here. Okay. And this is here a minus b, and you can take a half, and this is your x plus a whole to the power, and this is your minus half. Okay, same as half and x plus b whole to the power minus half. Okay, if we differentiate x is 1 and 1 is 0, so x is 1 and a is 0 here. So x square, derivative of sine means cos x cube, and derivative of x cube here is 3x square. Okay, again this is at twice x, we can write it twice x in sine x cube. So this is the answer. Okay, simplify. This is here 1 by root over of x plus a plus 1 by root over of x plus b, and see this is 3 into x to the power 4 into cos x cube, and 2x into sine of x cube here. This is your answer. Okay. Now proceed the question number 7. And students, see carefully. Okay, this is the most technical problem. You should always follow the step. Okay, see carefully in the first video, second video, then after this video, and this video is the most lengthy video. But take care and follow the procedure which I have proceed the system of derivation. Okay, now see carefully. So next is 7. For 7c, here is y equal to log x, log of tan x, and to the base x here. You know, derivative of log x, actually there is a to the base e, and then we get here differentiate, then we get here 1 by x. So here is x base. So we want to change the base here first, then differentiate. So we can like with the apply of logarithm, I take a base e here like that, okay. And now differentiate with respect to x by u by v method. This is the ddx of log tan x to the base e, and this is here log x to the base e. So apply the u by v method. So this is as a v, so this is v square, and here v is unchanged, and ddx of log to the base e here tan x, again minus log to the base e tan x ddx of log x to the base e. See, so this is here log x to the base e. Differentiation of log x, that is 1 by x. So x means here represent as a tan x. So this is 1 by tan x. Again ddx of x is 1, but here is tan x. So ddx of tan x is here sec square x. I think the students all better understood here. Okay. So again I repeat, differentiation of log x is 1 by x into ddx of x. As the derivative of x, not needed to write here, but here is log tan x. So we can write here 1 by tan x. Again ddx of in place of x, differentiate tan x. So you get here sec square x. So you write here, okay. And now log to the base e tan x. See, again right here derivative of log x. Clearly derivative of log x, that is 1 by x. Again differentiate of x is here 1. So I think students, all of you are better understood my explanation, okay. Now take a LCM x into tan x. So we can write here on that part. So x into tan x, and here is v square, that is log x whole square. So if we take a tan x, LCM tan x and x, so x are multiplied here. So x into log x to the base e, and also sec square x here. So minus this is here tan x and log to the base e tan x. Okay, this is your answer. Okay, follow this step clearly. Okay, I think all of you have better understood. Okay, this is a differentiation of 7 here. Now proceed to question number 8. Question number 8. See, take a y, yes, so that is here tan inverse. This is here cos x by 1 plus sin x and sine of log x. First of all, you should simplify for the inverse function, trivial inverse function. So how can proceed this simplifications? See carefully here. Okay, this is here y and tan inverse. Students, I think this is we can apply here the multiple angle, some multiple angle. Okay, so students, see carefully. I want to say all of you for the base of 11, 12 and the competitive exam, you should learn the formula of trigo, that is a compound angle, multiple angle, some multiple angle. This formula would be needed to apply here. Okay, so that's why learn the formula and apply the here. Okay, see cos x, we can write here like cos square x by 2. Okay, this is here sin square x by 2, and in place of x we can write sin square x by 2 and cos square x by 2, that is sin square theta plus cos square theta, but here is x. So in that part we are expand like 2 sin x by 2 and cos x by 2, that is the a and b, sin x by 2 and cos x by 2. In place of 1, so we can add here sin square x by 2 and cos square x by 2. Okay, so in place of 1 we can write here this. Okay, now sin x we can write here 2 sin x by 2, and this is cos x by 2. Okay, and sine and log x here. So this is tan inverse. So see, cos square x by 2 you can write here, this is x by 2 plus sin x by 2, and again cos x by 2 minus sin x by 2. Okay, this is whole square. So this is here cos x by 2 plus sine x by 2 whole square. So sine and log x. So see, the one factor are cancelled. So again, right here, and divide by cos x by 2 on numerator and denominator. Divide by cos x by 2. So if we divide by cos x by 2, so we get here 1, and also divide by cos x by 2, we take a tan x by 2 here, okay? Again see, divided by cos x by 2, so we get here 1, and also divided by cos x by 2, we get here tan x by 2. So from that, we can write here tan a minus b. So we can replace that tan 45 into, in place of 1, we can replace that tan 45. So this is the formula, tan inverse tan here pi by 4 minus x by 2, okay, and sine and log of x. So tan inverse tan, so left hand here pi by 4 minus x by 2, okay, and this is here sine log x. So differentiate both sides, dy and dx. So this is ddx of constant, that is here pi by 4, okay, and half into and ddx of x, okay, and again ddx of and sine of log x. Okay, this is here constant. So see, this is half into x. You know, students, there. If we think as a u into v here, so in my first video and second video, there was a discussion about like u into v. What is the rules there? Okay, u into ddx of v plus v into ddx of v. If we write this half into x, so half into ddx of x plus x into ddx of half. So that's why derivative of is 0. So not needed to write there. So like as a differentiate as a constant into x. So we can write here a into ddx of x and not needed to write as a u into v form. Okay, I think better understood why is this. So as the left hand x into ddx of a is 0, so not needed to write as a addition 0. Okay, only get here a into ddx of x. So like that. Okay, so and this is 1, and sin x here is cos and log x, and ddx of again derivative like sin x. Ddx of sin x we get here cos x, again derivative of x, that is 1. But see, sin log x and derivative of log x there is cos log x, again ddx of log x, that will be 1 by x here. Okay, so therefore that is half plus cos of log x, okay, by x here. Okay, this is the simplification of that. Now we have to proceed the question number 9. As in my previous video, this is not in this video. Here is the point number 2. In point number 2, there is more discussion. Just here is this is point number 1, and my video there was 6-7 points are discussed. That is variable to the variable. And see again, question number 9, 10. These two problems are also variable to the variable. So same as proceed 2 point. Okay, example number 2 here. So this is here 9. So y is equal to, have given there, that is x to the power cos square x. So we take a log of the value. This is variable to the variable. So we take log on both sides. So that is log x to the power cos square x and to the z here. So log y to the z and cos square x, and this is here log to the z x. So differentiate both sides. So needed to write here differentiate both sides with respect to here with respect to x. Okay. So don't write like dot 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 dot. Okay. You have clearly write here differentiate both sides with respect to here. Each and every set to be needed to write here. Okay. So ddx of, okay, yeah, ddx of cos square x and log x. This is to the base z. And differentiate again log x, that is 1 by x, and again ddx of x is 1, but here is y. As the question is given that this is a y and find ddx of ddx of this function, as it is a y. So y is also a variable and x is also a variable. So find the derivative of this means find dy by dx. So that's why y and x are both a variable. So in case of log x, we can write here 1 by x and here also ddx of x. But as we find dy by dx, sorry, not read as dy by dx, read only ddx of y. So that's why in place of y we can write here ddx of y. So this formation is as dy dx. Okay, now this is the u into v. So cos square x. Again ddx of log x to the base z here. Okay. Again log x to the base z and ddx of cos x square. This is cos x square. Okay, and this is here dy dx and y, 1 by y here, I am multiplying this part. So y means x to the power cos square x. And write this left hand side here. Oh, this is equal to this. And see, and this is here cos square x and ddx of x is by x. This is 1 by x. Again differentiation of x is here 1. Again right here, this is log x to the base z. So like a x square. So what is the derivative of x square? That is 2 come on the front and 2 into x to the power 2 minus 1. Like x to the power 100, 100 into x to the power 100 minus 1. Okay. So like that. So again ddx of x is 1. But here 2 into cos x and this is to the power 2 minus 1. Students, see carefully. More of the points are discussed. But again I repeat this. And ddx of cos x is here minus sin x. Okay. As needed to differentiate of x is 1, but here in place of x here is cos x. So ddx of cos x is minus sin x. Okay, like that. Okay, so again x to the power cos x, cos square x. So cos square x by x minus 2 sin x cos x, that is sin 2x from multiple angle. Okay, and this is here log x to the base c. So this is the question number 9 here. So not needed to explain the question number 10 here. Okay, same as positive you follow. Okay, now I follow the question number 11. That is y equal to x into e to the power x and e to the power 3x by e to the power x and plus e to the power minus x here. Okay, and that is take a common e to the power x from the numerator. This is here 1 and this is here twice x. So this is here e to the power x and you can write here 1 by e to the power x. Okay, this is x into e to the power x and take a LCM. So I write here e to the power x and this is here 1 plus e to the power 2x. So again e to the power x, e to the power x, this is e to the power twice x plus 1. So these are 2 are cancelled. So x into e to the power 2x. So this is y. So again differentiate ddx of y and you apply the u into v rules. So that is here x into e to the power 2x. So this is x into ddx of e to the power 2x. Again write here e to the power 2x and ddx of x. So x into e to the power 2x. So e to the power twice x. Again differentiate twice x. We get here 2. So e to the power twice x and ddx of x is 1. So take a common e to the power 2x. So this is 2x plus 1 are left here. Okay, this is another factor. So this is the differentiation of that. This is question number 11 here. Now I want to follow the question number 12. See. Question number 12. See, this question number looking like so critical, but if we simplify, then you get us easiest form. So see, this is some of the students who started just initially derivative. So those students are so some problem. Okay, now log of a by b. So you can write here log of e to the power x here. So now to the power z x to the power x divided. So take okay. So this is tan x by x. So this is here x r and e base is here 1. Okay, now x into log x to the power z here. I take a common x. So you get here tan x by x and x here. This is here 1 minus log x to the power z. So x are cancelled. So we get here tan x into 1 minus log x to the power. So we apply the u into v method. So differentiate both sides. That is here like ddx of whole thing, and that is u, and ddx of here 1 minus log x to the base e here. So plus 1 minus log x to the base e into ddx of tan x. So this is here tan x, this is 0, and derivative of log x, this is 1 by x. Again 1 minus log x to the base e, and derivative of tan x, this is x square x. So this is here tan x by x. So this is here 1 minus log x to the base e, this is x square x. Okay, this is question number 12. So 13, see 13. And given that cos x, this is a cos x to the power y, see, sin y to the power x. So see, this is also a variable to their variable, so I needed to take a log on both sides. So you have to the base e cos x to the power y, and log sin y to the power x, and to the base e here. So therefore y into this is your cos x, so x into log sin y to the base e here, and again differentiate both sides with respect to x, so you can apply the u into v, so u into ddx of v, so log, okay, this plus log cos x to the base e into ddx of y, again x into ddx of log sin y plus log sin y into ddx of x here. So y, differentiation of log cos x, that is 1 by cos x, and differentiation of again cos x is sin x. So same as log cos x, so derivative of y is di by dx. Okay, this is equal to x into log sin, this is by sin y, and ddx of sin y, that is cos y. Again repeat ddx of x, you can for this variable as we differentiate log y, and that is the variable y. So that's why 1 by cos y, and derivative of cos y is sin y is cos y. And again repeat in place of ddx of x, and here is ddx of y. Okay, plus so we can write here like here take a common di by dx. So this is your log to the base e, and this is your cos x, and this is shifted to the left hand side. So this is here x into cot y, and this is equal to log sin y, and minus, these are shifted to the right hand side. So we get here, this is here minus, so as a plus y into tan x. Okay, and this part are divided by the right hand side, then we get the answer. Okay. Sorry, not 40. This is 14. This is here e to the power xy minus 4xy, and this is equal to 4. Again differentiate both sides with respect to x. So ddx of e to the power xy minus 4 into ddx of xy, and the derivative of 4 is 0. So right here derivative of x to the e to the something is e to the something. Again differentiate xy, x into ddx of y here, and y into ddx of x is 1. Again you can write here x into ddx of y is di by dx. Sorry, I wrongly said not di by dx, that will be ddx of y, okay. And this is y and this is 1. We take a common is this. So x into dy dx plus y here. So it will be by xy minus 4. But it is by xy never is 4 here. Okay, this is the exponential. So never be 4. And so therefore x into dy dx plus y equal to 0. Okay, that is equal to minus y by x, and this is your answer. Okay, see, this is 14. Now we want to do the question number 15. Is that same question like 10, 9, 2 and more of the part of 2 is same question like 15 here. It also gives that the variable that is y to the power y, and there are the two sides left and right, no the addition form, so we can take a logarithm on both sides. So y to the power y and log sin x to the z here. Okay, we can write here y and log y to the z here sin x. Differentiate both sides. Okay, so that's why y into ddx of log y. This is here log y to the z, and also log y to the z into ddx of y. This is the apply the unity product rules. Okay, and also ddx of log to the z here sin x, and we can write here y into derivative of log y, that is 1 by y. Again repeat, if there is a x and derivative of x is 1, but derivative of y we can write here dy by dx. I repeat. Okay, same as log y to the z, and it is symbolized by dy by dx. And this is your log sign. You can write here, this is respect to x, okay, and function is x also. So you can write log x, this is 1 by x. And differentiate of x, it means that is a sin x. And ddx of sin x, we get here cos x. I take a common dy by dx here, okay, then this is the required part, this is dy by dx. So you can write 1 plus log y to the z here. So this is here cot x. Cos by sin is cot x. So you can write dy dx, and that is equal to cot x by 1 plus log y to the z. So this is your answer. Okay, I repeat question number. No, not repeat. There is the implicit function x and y are given. X is the function of t, and y is the t is called the parameter, and we have to derive it with respect to the t, and also differentiate y that also are subject to the t. This is the parameter function with the parameter t. So first find dx dt and also dy dt, and then divide dy by dx, dy dx, and then we get here dy dt and divided by dx dt. Okay, so right like now. Okay, 16, that is here x is equal to a into here t minus sin t, and again y is equal to a into 1 minus cos t at t is equal to pi by 2 here. Okay, now differentiate this dx dt. So you can write here differentiate with respect to t like it x. So same as this is 1, and derivative of sin, this is cos t, you can write. And also dy dt with respect to t here, as the function is there subject to the t. So a and constant, derivative of constant is 0 here. So this is here cos t. So you can write here plus sin t. Okay, so that's why you can write dy dx, that can be written as dy dt and divided by dx dt here. So derivative of y, that is dy dt, is a sin t, and here is a into 1 minus cos t. So same as at what point we want to find the value of dy dx, that is at t is equal to pi by 2, and this is the question at t is equal to pi by 2 here. Okay, so a into sine pi by 2 by a into 1 minus cos pi by 2. You know, the value of sine pi by 2 is here is 1, and also you can write here a, and also cos pi by 2 is 0. So you can write here 0, so 1 minus 0 is 1. So this is here 1, your answer. And question number 17 is also the same. So follow the 16 number question. Okay. Now we have to show the question number 18. Okay. This is our 18. We have given x is equal to sec inverse, that is 1 plus t square by 1 minus t square, and that can be written as like cos inverse 1 minus t square by 1 plus t square. Another is here y is equal to what here? What? This is tan inverse. This is tan inverse 3t minus t cube by 1 minus 3t square. So let us take parameter t as a tan theta. So you can write x is equal to cos inverse 1 minus tan square theta by 1 plus tan square theta. So you know the formula of 1 minus tan square theta by 1 plus tan square theta. This is cos 2 theta, you can write. Okay, this is cos 2 theta. So that is equal to cos inverse cos. So you have left here 2 theta, and also y is equal to tan inverse is equal to, if we put in place of t like tan theta, that is the formula of multiple angle. We get here tan 3 theta. Okay, this is the formula of tan theta, tan 3 theta. So tan inverse tan 3 theta. So theta. So now differentiate x with respect to theta. So now this is the parameter of theta. So this is, we get here 2, and same as differentiation of 3 theta with respect to theta. Okay, there is 3. So now find dy dx. You can write dy d theta and dx d theta. Okay, so dy d theta value is 3 and is 2, and this is 3 by 2, your answer. Okay, so now follow the question number 20. In my some videos, somewhere I was introduced this type of problem. There was 1 minus x to the power 50 and 1 minus y to the power 50, and there is a into x to the power, sorry, this is 100, 100, this is 50, 50. So same procedure, you can use that procedure, can easily get the solution and see what is the technique here, find dy by dx. So let us assume x is equal to as a sin alpha and y is equal to as a sin beta. So put these two x and y in this equation, so you get here cos alpha, again you get here cos beta, and now a into this is here sin alpha minus sin beta. Okay, students, see the technique here, 2 into cos of alpha plus beta, and this is here cos of alpha minus beta by 2, and also a here, and this is also 2 into cos of alpha plus beta by 2 into sin of, this is here alpha minus beta. So you can simplify 2 and 2 are cancelled, and also here cos and cos, this factor are cancelled. So you can write again this divided by this as a cot. So this is alpha minus beta by 2, cos by sin is cot, so a here. So cot are shifted to the like an inverse, so that can be written alpha minus beta by 2 into cot inverse a. See, this is a constant, so differentiation of this is 0. So 2 are shifted to the right hand side, so alpha minus beta into 2 into cot inverse a here. And now alpha means is this, okay, this is sin inverse x, and this is here sin inverse y, okay, this is alpha, and 2 into cot inverse a. So again differentiation is this. So now write the formula here, students, see, this is the formula, new formula, this is sin inverse x is always 1 minus x square. So learn this formula, derivative of sin inverse x is and that is 1 minus 1 by root over 1 minus x square. So you get here root over 1 minus x square. And again differentiation, this is 1. But here is differentiation, and that is 1 minus x square. And this is derivative of ddx of x. ddx of x is 1. But here is y. So ddx of y. So this is here ddx of y. So question is there, find dy by dx. Sorry, again I wrongly said. Not dy by dx. This is read as ddy of dx of y. Okay. So this is 1 by root over 1 minus x square. So this is here root over 1 minus y square. And this dy dx. And this is transferred to this part to the left hand side. So we get here dy and dx, and is equal to root over 1 minus y square, and this is root over 1 minus x square. This is your answer. And see here, this is 20. Now the next point is 21, and there is a 21, 22, and these are all the same question. So we follow the 21 here. Okay. Y is equal to root x, and this is root x, and this is root x to infinity. Okay, see, these are repeat. So if we eliminate this, and this part we also we can write as a y. So root x to the power as a y. So that is x to the power y by 2. So see, this y and this is also variable to the variable. So we take a logarithm on both sides. So log y to the base z, and also log x to the power y by 2 to the base z here. So this is half y by 2. Okay. Now y by 2 into log x to the base z. So differentiate both sides. Okay. So we can write ddx of log y to the base z and half ddx of y log x to the base z. Okay. Differentiate 1 by y, we get here, and dy by dx also, and a half, this is here y, ddx of log x to the base z, and again write here log x to the base z and ddx of y here. Okay, so dy dx, this is here 1 by y, and half, and y, derivative of x is 1 by x, so log x, and this is where, and dy dx. So you multiply half, this is 2, and this is 2. So you take a common dy by dx. So this is here 1 by y minus 1 by 2 log x. So y by 2x here. So therefore we can find dy by dx is equal, this is y by 2x, and this is here 1 by y minus half and log x. And we take an LCM and simplify this question. Okay, so this is your explanation, and see carefully, this is your answer.